Okay, so for today's deep dive, we're unpacking some really interesting source material.
We really are.
It's essentially a spec sheet for a piece of hardware. The Thor Broadcast H-Petit-12CH-RM,
A very long name.
a very long name for a 12-channel digital CATV and RF distribution system.
Which sounds incredibly technical, but the actual problem it's solving is something you can easily picture.
Right, and that's our mission today. Let's figure out the engineering challenge here. How do you take a dozen different HD video feeds and just blast them across a huge venue all at the same time?
Well, the scale is the whole point. You have to think about a place like a giant hotel, a stadium, or even a big corporate campus.
A sports bar with TVs on every wall.
Exactly. They've got maybe 12 different sources, cable boxes, media servers, digital signs, and they need all of them to get to hundreds of screens.
And you can't just run a bunch of super long HDMI cables for that. It just doesn't work.
No, it's a nightmare over any real distance. So this system, what it does is it takes all those feeds and pushes them out over the building's existing coaxial cable.
The old school TV cable that's already snaked through the walls.
The very same. It's cheap, it's reliable, and crucially, it's already there.
And looking at the design, the way they handle that complexity is, well, it's all modular.
Completely. It's not one giant, complicated machine.
It's a rack-mountable chassis, and you can just slot in up to 12 of these individual Petit units.
And each one of those is basically its own little micro-broadcast engine. It grabs a single HDMI input.
And the specs confirm it's HDCP compliant, which is critical.
Oh, absolutely. That means it can handle pretty much any protected content you throw at it. Your cable box, a Blu-ray player, whatever.
So its whole job is to convert that clean digital video into a broadcast-ready radio frequency signal, an RF signal.
That's the whole magic trick.
So let's talk about the encoding for a second. They're using MPEG-2, which, feels a bit old school in a world of H.254 and modern streaming.
It does, but it's a very deliberate choice. It's not about cutting-edge compression. It's all about rock-solid reliability over those existing cable standards.
So purely for compatibility.
Purely. MPEG-2 is the established workhorse for cable. It just works. They pair that with AC3 audio for the digital sound.
Right.
But the part I find fascinating is the bitrate flexibility. The spec says 19.3 megabits per second, but
it's adjustable.
It's very adjustable, all the way from 2 up to 24.
That is a massive range. So what's the trade-off there? Why turn that knob up or down?
It's a classic engineering balance, really. It's all about channel density.
Okay.
If you only have a few channels running, you can crank that bitrate towards 24 for absolutely pristine video quality.
Maximum fidelity.
But if you need to squeeze all 12 channels onto that one coast network, you dial it back. You trade a tiny bit of video quality, maybe, for the ability to pack more services onto the cable.
So once the signal's all compressed, it has to get out there. And the power output is specified at what, plus 24 dBmV?
That is a lot of juice. And that number tells you it has enough power to feed hundreds of TVs, even after going through all the splitters and long cable runs that eat up signal.
So it's purpose-built to overcome that signal loss, that attenuation.
Exactly. And it's adjustable, too, from 70 to 100 dB, so you can fine-tune it for the specific venue.
The other thing that really stood out to me was the flexibility in the modulation. It's like a universal translator for TV formats.
It really is. It can be set to QAM, ATSC, DVB-T, or ISDB-T.
So that covers pretty much every major broadcast standard around the world, right? US, Europe, South America.
The works, and you manage all that complexity through the network management system, the NMS.
Right, you just access it through a web browser on your computer.
You plug it into your network, pull up a graphical interface, and you can configure everything remotely with incredible precision.
So what this all means for you, then, is that this equipment isn't just splitting a signal. It's not an amplifier.
No, not at all.
You're actually running a private, professional-grade, 12-channel digital broadcast network inside a single building. It's true micro-broadcasting.
And this brings up the most interesting point for me. When you're in that management system, the level of administrative detail you control is just staggering.
What do you mean?
You're setting things like the service provider name, the network ID, and even the TSID, the transport stream identifier.
Which is like the unique DNA tag for that specific channel feed.
Precisely, and it raises this really provocative question. How much do these complex, localized digital TV systems actually mirror the architecture of the giant regional cable networks we all rely on? You aren't just sending a video feed, you're essentially configuring your own mini telecom carrier.